Hey YouTubers, thanks for joining me here at Random Chemistry. In this video, we're going to continue to practice converting molecules to grams and grams to molecules. Here's our first question. How many molecules are in 34.9 grams of H2O? We're going to solve this using dimensional analysis. If you prefer using the MAP strategy, you can go back to my introduction and I show you how to do that. Before we can go to molecules from grams, we need to find the molar mass of H2O. And you can do that by looking at the periodic table. If you're not familiar with that, I got a video on molar mass too. So the molar mass of H2O is 18 grams per mole. And then we also have to be familiar with Avogadro's number. So molecules, it's 6.02 times 10 to the 23rd per 1 mole. So these are our two conversion factors that we're going to use in our dimensional analysis equation. So we need to start with what we're given. 34.9 grams of H2O. So we have grams of H2O. If we have it on top, we need it on bottom. So we're going to use our molar mass as a conversion factor, which is 18 grams per 1 mole. So 18 grams of H2O for every 1 mole of H2O. Grams canceled, and I'm left with moles. Now I need to use Avogadro's number as a conversion factor. And if I have moles on top, I want moles on bottom. So 1 mole of H2O has 6.02 times 10 to the 23rd particles or molecules. So now moles cancels and I'm left with particles or molecules, which is what the question is asking me for. Now I put this into my calculator. 34.9 times 1 divided by 18 times 6.02 divided by 1. When I put that into my calculator, I get 11.67 times 10 to the 23rd. Now this isn't in scientific notation, so even though it's the correct answer, your instructor might mark you off for it. To put it in scientific notation, we need to move our decimal point to the left. So it would be 1.167. And since I moved my decimal point to the left, that's going to increase my exponent. So that's going to be 10 to the 24th particles or molecules of H2O. Here's our second question. How many grams of sodium chloride are in 1.79 times 10 to the 25th particles of sodium chloride? The first step is to find our molar mass of sodium chloride. Which is 58 grams per 1 mole. So that's our conversion factor, that's our molar mass. And then we need Avogadro's number, which is 6.02 times 10 to the 23rd for every 1 mole. So those are the two conversion factors that we're going to use. So 1.79 times 10 to the 25th particles of sodium chloride. If I have particles on top, I need particles on bottom, so I'm going to use Avogadro's number as a conversion factor, 6.02 times 10 to the 23rd particles of sodium chloride for every 1 mole of sodium chloride. So particles cancel, just the particles, not the times 10 to the 23rd, because it can't cancel out. You have 10 to the 25th and 10 to the 23rd. So now that I have moles on top, I need moles on bottom, so I'm going to use my molar mass. So if I have it on top, I need 1 mole of sodium chloride and then 58 grams of sodium chloride. So moles cancel and I'm left with grams of sodium chloride, which is what my question is asking. So now I can plug this into my calculator. 1.79 times 1 divided by 6.02 times 58. When you plug that into your calculator, you should get 17.395. And now we need to worry about our powers of 10. So when you're dealing with exponents, when you're dividing exponents, you just subtract them. So 25 minus 23 is 2. So our answer is 17.395 times 10 to the second power grams of sodium chloride. But your instructor probably won't accept this answer because this is scientific notation. They're probably going to want it in standard form. So all you have to do is move your decimal point 2 places. So your answer is going to be 1739.5. So 1,739 grams of sodium chloride. So this is standard form, and that is your answer. Alright, YouTubers, thank you so much for joining me during this video with random chemistry. Please comment, like, subscribe. I really want to hear from you. If there's any material that you specifically want me to cover, if you have any questions, please leave me a comment. Thank you again for joining me, and we'll see you next time on Random Chemistry.